Dear students, welcome and thank you for tuning in to this video. We're still talking about diffusion. This is the fourth video from the diffusion lecture. In this video, we're going to talk about the applications of diffusion in solids, how we are using diffusion in processing solids and metals. I'll show some examples of how diffusion is important in a processing. So when we talk about processing, it means that how am I going to change the properties of a material or change the structure of a material during its manufacturing. One of the examples or the applications of diffusion is something called case hardening. We use diffusion to strengthen a particular metal. We can diffuse carbon atoms into a material made of iron or a part of a machine made of iron by placing the carbon atoms on the surface, and then we let it to diffuse, and this is called case hardening. Keep in mind that carbon is smaller atoms compared to iron, way much smaller. So which means that if the carbon atoms tend to diffuse into iron, the mechanism that's going to happen is interstitial diffusion. If you look at the image on the right, this is an image of a gear. We can use carbon to harden the gear by diffusion. So if we placed carbon on the surface or we mix it with iron, carbon atoms will diffuse interstitially. The result of the presence of carbon will make the iron steel harder. So we can make a gear of steel, and if you want to make it harder, we can let carbon to diffuse inside that material. Carbon is like an impurity, and carbon will hinder the movement of dislocations of the iron, and that's why we call it case hardening. Another example of the use of diffusion in solids is something called doping. One of the examples that illustrate this process is silicon with phosphorus to create N-type semiconductors. So how this is working is that we have, if you look here, we have a silicon block. We place or deposit phosphorus-rich layers on the surface, and if we heat it, after heating, the phosphorus atoms will diffuse inside the silicon, and we call it dope semiconductor regions, where the phosphorus will diffuse and distribute inside the silicon to be a new structure. And this is continuously used in semiconductor processing and manufacturing. And this is examples of how we're using silicon atoms and aluminum atoms to create a semiconductor. I hope that this video illustrated two applications or two examples of processing that we're using in solids and metals benefiting from diffusion. Thank you, and until next time.